All right, looks like everybody's on. I don't know if you've ever used GoToMeeting either. This is something that I use quite a bit in my work. So there are a couple functions. There's a chat function, which I will try to check occasionally, but it's hard to check the chat and also present. So if you definitely want to get my attention, the best way is to unmute yourself and talk. You can also use the raise your hand function, which is literally just a little hand in your GoToWebinar control panel. And I'll try to scroll over to the attendee list occasionally and check that list out as well. But thank you guys all for being flexible. I just couldn't get Zoom to work tonight. Everything else is working. Internet's working. Canvas is working. GoToWebinar is obviously working. If I could get at least a couple of you to raise your hands to know that you can hear me. It looks like you're hearing me. All right, thanks, Corinne. Everything looks good on my end. All right. So I wanted to start off first by saying, in general, how good the Animoto 2 projects were. You guys, most of the groups really dialed in the details of that project, and some of the videos were actually just really spectacular. There were some that did some Halloween themed music, etc. It was a fun project to go through and grade and see what you guys are learning about your instruments, your measures. So that was quite fulfilling overall. The first thing I wanted, so I don't really have, there were no real patterns of responses that I felt concerned about. Most of you seem to get the criteria and what was required and were responsive. Some asked questions a few days in advance, which I was able to answer, which helped. Hopefully you guys all got the feedback. I mentioned in the responses, but I went through your reference lists if you provided one in Word. And I was able to edit those using track changes to show you what it should look like in an APA consistent format. If you did not submit a reference document in Word, but you did have it in your Animoto video, I of course gave you full credit for that. But if you didn't submit it at all, of course, that was a different story. If you didn't submit it in Word, but you want to, because you want to get APA feedback about what reference lists should look like, I'm happy to do that for you. I think there was one or two groups who had it in their videos, but didn't submit it as a separate Word document. So I'm happy to do that work anytime if you want to email me a copy of your reference list. There were a lot of, the APA stuff is of course something I haven't taught you directly, which is why it's not being graded. But there were a number of edits required for the APA style. So there's definitely a need for you guys to get more invested in looking through the APA book, particularly the references section. And it's super detail oriented. Your professors are of course going to be really hard on you on that particular issue. I don't know why, but it's something that everyone pride themselves on, being able to catch everyone else's errors in APA, I guess. But there weren't any that were, that didn't have at least 10 to 15 errors. And they can be really small things, but they all add up when you start looking at the overall track changes. So if you have any questions about the APA style, you can ask them at the end of class today, or I'm happy to answer any of those through email as well. But hopefully I tried to put comments in to explain the rules that I was applying for the most part in the track changes edits that I incorporated into your documents as well. So I wanted to explain Animoto 3 next. Animoto 3 is actually going to be not a whole lot of work, which is one of the reasons why it's due next week instead of 2 weeks from now. We also have Animoto 4 pending. But Animoto 3 is basically the really simple, I hope simple task of incorporating the scoring instructions and or decision rules from your measures into the construct map. I'll show you an example of what that looks like. And also incorporating the scoring information from your technical reports into the Animoto video. So I'm going to start today's class after reviewing Animoto 2, obviously, with going over your pending Animoto 3 project. As long as there are no questions about Animoto 2 that any of you want to levy, I'll give a couple second pause for you to unmute if you want. All right. Okay, so the Animoto 3, and Brent and everyone else, let me know if it's visible. I have it about as big as I can possibly make it. I'm hoping it's large enough for you. The Animoto 3, as I mentioned, is really about scoring. So the Animoto projects go in phases. The final phase gets you looking at all of the technical adequacy information. But phase 3 is literally looking at how to interpret scores using your technical report as your source of information, your technical reports. So within each of the technical reports, there are scoring rubrics. There are Likert scales or rating scales sometimes. Sometimes there are a series of scoring instructions. Let's say you have a behavior rating tool, for example, and you're supposed to circle a 0, a 1, or a 2, and those mean, never, sometimes, always, for example. So the scoring instructions for that would be you have to circle a 0 or 1 or a 2. This is what the 0, 1, and 2 mean. Within each subdomain, you provide a raw score sum. Those raw score sums are converted into scaled scores within each domain. The subdomain scores are then combined for an aggregate or composite score that is also transcribed into yet another scale, etc. So that was a behavior scale example. If you're more of on the achievement test side of things, you're going to be saying, for example, the student can get 0 points or 1 point for each item. There are 36 items. So the raw score out of 36 is converted into a scaled score using IRT. And of course, these details are going to be different for your test. For your measure, I'm just giving you kind of an example of the types of things that are discussed in the technical reports. So basically, any way that the items are scored, whatever scales they're scored against, how raw scores and whether raw scores are converted into scaled scores, all of that information goes into the category of scoring rubrics and decision rules. Okay, and decision rules can also be the structure of the assessment. For instance, some of your assessments are likely have the items in order from least to most difficult. Oftentimes, they will have what's called a basal, which is where you start the assessment. Based on students' age, oftentimes, but it also can be based on other factors. So, for example, if you have an 18-year-old taking an IQ test, you're not going to start the 18-year-old on item 1, whereas if you're giving the same version of the test to a 2-year-old, you probably are going to start with item 1. So they use those basal and ceiling, the basal guidelines at least, as a way of trying to save as much time as possible, not administering items that should be too easy for a particular student. So the decision rules come into that. So if you start, let's say the 18-year-old, you start that student on item 10, but they miss the first 5 or 6, depending on the assessment. Oftentimes you have to go drop down 5 more items below and administer from items 6 through 9, for example, 6 through 10, 4 through 10, that's what I was looking for. So all of those types of decision-making aspects of a measure are within the decision rules category. So decisions that you have to make that are based upon how a student is being scored live during the test administration. If you are doing an academic achievement test, for example, your decision rule might be that test administrators are allowed to discontinue testing if the student misses the first 10 items of an assessment, for example. That's one of the rules that we have on the Oregon Extended Assessment. Or if the student at any point during the assessment misses 5 or 6 or 10 items in a row, you're allowed to discontinue testing because the odds are that they will not, there's a very high probability rather that the student won't be able to respond successfully to an even harder item when they've missed 5 or 6 in a row that are easier. So those are all the aspects that go into the decision rules category. So that's really kind of the gamut of what we're looking for. Anything else that might relate to scoring or score interpretation might come into the guidelines category here. So we've got the scoring rubrics, which is literally how to assign points, how to assign numbers to behaviors. The decision rules cover what is done with those numbers and how that might affect test administration approaches. And then the guidelines is kind of a catch-all for any other information that might be associated with the scores, such as scoring, interpretation, etc. Okay, I'm going to give you guys a second to digest that and check out the question. I see that I'm getting a question here that I want to ask or want to answer. Okay. Oh, okay. So some of you are not able to unmute on your end. Excellent. Let's do this. I can unmute you. So if you just send me a question and say, please unmute me, I'll unmute you so you can ask. All right. And I am not sure what's going on with the audio. I'll make Adam, if you don't mind, since you're on, I'm going to make you a organizer so that you might be able to help me manage some of the chat functions, if that works. Okay, good. So, and Trevor, I'm going to go ahead and unmute you, and then as I'm doing that, I'm going to answer Gina's question. Gina's question is this document posted online? Yes. This exact same information is also on Canvas, just as as part of the information about Animoto 3. I had one of you last week asked me to post the information for the Animoto projects in Word documents as well. So this Word document will be posted online. It is online on Canvas already. I downloaded it from Canvas. All right, so Trevor, you should be unmuted now. Looks like you're green and good to go if you have a question. And I'm not hearing you, so maybe there's a microphone issue. I'm going to leave you unmuted. So if you can figure out your microphone issue, just
can you hear me now?
Yeah, there you go.
Okay, sorry about that.
No, it's okay. This is a new platform. We're learning.
No, so I was just considering some of the back and forth that we had this weekend about where Brent and I were at with the assignment that we submitted. Was there? Did you just mention a few minutes ago there that there's a possibility for an example that you could post as far as like what the updated construct map will look like here?
Yes. Yeah. And in fact, okay. I'm just about to talk about that, and I have an example that I'm going to talk with you about of the updated construct map that I'm expecting, and then I will post that version. I think that I already did post that version to Canvas. Last week too.
Thank you.
But I'll certainly go through that. You betcha.
Okay.
And actually, from now on, it looks like I have to unmute you from my end. Sorry. So just raise your hand or shoot me a question in the question arena if you want to ask a question out loud. You can also just type the question in the question box and I'll just answer it. Okay, so raise your hand if you have any question about what kinds of information kind of comes in the scoring rubrics domain versus decision rules that are associated with scoring versus kind of the catch-all about scoring guidelines. And again, if it probably won't make as much sense to you now as it will when you start diving into your technical reports. Some of you have already started including scoring information in your Animotos, so that is going to be old hat for some of you. Kevin, it looks like you have a question, so I'm going to unmute you here. And you should be good to go. Go ahead, Kevin.
Okay, can you hear me all right?
Yep, sure can.
Awesome. So we are looking at at least in part, SBAC, the Smarter Balance Assessment.
Right.
And individual items have different specific scoring rubrics. So like each item has its own rubric for like, if this is what the answer looked like, you get 1 point. If this is what the answer looks like, you get 2 points.
Right.
Kind of deal. How would you recommend incorporating that sort of thing, since
that's a great question? I want you to go through the 45,000 item bank for SBAC.
Perfect.
Tell me how each one is scored.
Perfect.
No.
Perfect.
Great question. How about you look at a sample and give me an idea of what the gamut is. So there,
Okay.
for example, there are some items that are selected response with 5 answer choices, and students get 2 points if they get them right, 0 points if they get them wrong, or 1 point if they get the closest distractor. There are other items where it's scored on a rubric, writing items. Sometimes writing items will be scored differently than math items, of course, and math items differently from ELA. So I want to see kind of the pattern of scoring responses in that kind of situation. I definitely don't want you having to write out every single scoring instruction. Or you can even just say SBAC has different scoring instructions for every single item. They range from blank to blank.
Gotcha. Yep. Okay, sweet. Thank you.
Gotcha. Mm-hmm. All right. I'll mute you again. Let me scroll through and see if anybody else has hand raised. Nope. Yeah, and this is a point that one of you made, and it's just true. You never have the questions, of course, until you're literally trying to apply what you might have thought you learned during Tuesday's class to the actual assignment. So for this class in particular, there have been chunks of time where I haven't been available because I've been in a car. But I do, I religiously check email on weekends and evenings and during the working hours, of course. So anytime you have a question, if I'm awake, it will get answered, or it'll get answered as early as possible the next morning. Because I know I call those steppers. They're things you didn't think to say until you're walking down the steps out of the building or out of your presentation, etc. All right, so please don't hesitate to send me emails over the weekend. I'm happy to make sure there's clarity as you guys work through this process. Okay, so that's that first bullet really applies to the kind of Animoto context, the information you're going to add to your Animoto. And it might even make sense to add a slide for scoring rubrics, a slide for decision rules, and then a slide for guidelines. You guys can decide that, and of course you might want to add 2 slides each, of course, because of 2 measures. So in terms of bullet 2, it's really about the information you need to add to the construct map, and it's simply item scoring information. So I'm going to switch gears here and minimize that, and I'm going to bop over to an example of a construct map that I developed to show you as an example for tonight. I'll make it bigger. So this is something that some of you already did as well, I think out of a small bit of confusion, which is adding the scoring instructions that correspond to the respondent descriptions to the construct map. So it should quite literally be what scores, whether that's a scaled score or scores within a certain range, etc., correspond to the respondent descriptions that you have recorded on the left. So you can see this is, I'm building this construct map about counting forward with you. So the definition now has gotten a lot more detail on it. We've used, instead of having item descriptions here now, you'll notice that it has scoring descriptions, okay? So these are the range of RIT scores on this particular test. This is a hypothetical test. It doesn't exist. That correspond to students with the lowest counting skills, students with lower counting skills, mid-range, and then highest. So in order to get And for SBAC, you can literally substitute the labels for the highest performance level, et cetera, all the way down, although I believe they have 5 for SBAC. So, but literally it would be the RIT scores that correspond to the highest level, the next level lower, the next level lower, et cetera, for an academic context. If you are working with a behavior scale, you are more than likely going to be putting the behavior scale system in here. So that could be the summative scoring process that occurs at the end. So if you have scaled scores that get converted into such and such a number, the numbers in this range correspond to somebody who is at risk. The numbers in this range correspond to somebody who's not at risk. So the scoring levels for an assessment like I was just talking about literally would just have 2 categories, not 4 like the one I'm showing you here. You're either at risk or you're not at risk. So this is literally all you have to do is go back to the either the first or the second. I know the online instructions say to adapt your second construct map, probably because it'll have a better construct definition. But whichever construct definition I've accepted for you, keep that because that's good. Keep your respondent descriptions. Most of you have done a very good job about that. And instead of the item descriptions that you included last week, add the scoring requirements that correspond to that level. So for example here, you can see that to go up from lowest counting skills to lower counting skills, you have to get not a 200, but a 201. To go from lower to mid-range, you have to get a 301 instead of a 300. To get the highest counting skills on this particular measure, you have to have gotten a score that's greater than 400. So you can kind of see how incrementally the higher the score is, the higher the student's counting skills are based on this particular hypothetical mock-up. The other aspect is if it's a scale that may not be incredibly familiar to most users, you're expected to provide some recommendations about how to improve the scale based on your experience, and that can be your experience as a result of one of the readings that we've covered. That can be your experience as a teacher, trying to figure out what scaled scores mean and how you went through that process and what really helped you understand what scaled scores mean. It can be your experience as a parent when teachers were trying to tell you what a 22 on an easy CBM test or what a 900 on the Oregon Extended or what a 9,000 something on SBAC is. What do all these scores mean? So those are the kinds of information tidbits that would come in the recommendations section. So for my example that I'm sharing with you, my recommendation is that this fixed scale is specific to the assessment, and it's not possible to accurately interpret because you have literally nothing to compare it to, right? I don't know what a 210 means on this assessment compared to a 310. All I know is my student got a 210. So what I'm recommending is that the information provided, so the scaled scores provided here, would be improved if there were achievement level descriptors that explained what performance within each scaled score range means. In other words, if you get a score of less than or equal to 200, what are the kinds of skills that you probably are able to do, and what are the kinds of skills that you probably have great difficulty doing? That would tell me something about what the scores mean. What's another option that helps you compare test results? Helps you understand what they mean. So one option is describing what they mean with text. What are some other examples that you've read about either this summer or this fall in this course? And that could be, you can type your answers into the question box or raise your hand and I'll unmute you. All right, Molly, I'm going to unmute you. You should be good to go.
Okay, I had a quick question about the construct map. So we're doing ALPA 21.
Yeah.
And there is like emerging and proficient, and then there's also the cut scores. So do you want 2 different construct maps or put the 2 combined into the different levels?
Great question. No, as the construct maps are always specific to the test. So you guys are going to be doing 2 construct maps, 1 for each measure, because they should have different scales and different cut scores, etc.
Right, so it has the different cut scores, and then it also has progressing, proficient, like 3 different levels. So do you want those 3 different levels embedded in what the cut scores are, or do you want the different levels on a construct map and then the cut scores on a different construct map?
What I would suggest in that case is these labels. I'm going to explain something about the construct map because your question kind of belies a point I've been trying not to make, but I'm going to have to. The left-hand side of this are really, in an achievement context, correspond to your performance labels, right? So exceeds, proficient, nearing proficiency, basic, those kinds of things. So with the example you just shared, it'd be really easy just to use the labels straight out of the ELPA 21 to define these respondent levels. And then over here, you would put the cut scores that match that label in the scoring instruction side. But the structure of the construct map, I wanted to explain a little further. Yeah, you bet. And I'll leave you unmuted for a second because I'm not positive you're done. But these are all of the personability statements. Remember when we studied, we talked about IRT, how personabilities are measured on the same scale as the items and item difficulty. And the item difficulty that matches here matches the personability over here. So this entire construct map is literally built upon that premise. So these are the descriptions that describe the kid of different personabilities on the left. On the right-hand side, for this particular Animoto project and this construct map, you're describing the scoring or the ranges of scores that correspond to those labels. So last week, what we were doing instead is writing the item content that corresponded to performance at these levels. So I hope that is starting to make more sense. But this scale, this arrow right here, you can start thinking about that as having literally a distribution of item difficulties over here and a distribution of distribution of person abilities over here. Okay, that's really what we've been working toward is building your understanding of that connection. Does that address your full question, Molly?
It does. Thank you.
Right. You bet. All right. No other hands raised. And I see a couple questions that I'm going to stop and address here. Oh, good question. One question I got is this is an answer to my question. So yes, the other answer to my original question was, yeah, norms. The only other way that you can figure out what a score means is how that score compares to other students in a sample or in a set of normed sample. So another population of students that's representative, for example. So I had a couple of you weigh in on that. So age-based norms, grade-based norms, those are perfect recommendations. If your assessment lacks those things really help test users of test information understand what the scores mean. Another great answer is that you can look at how scores compare to other assessment scores. So if this student is getting, a 200 on the Oregon Extended Assessment, a grade 4, what did they get on EasyCBM? Do you start seeing a pattern of very low scores? Then you can kind of relatively know about how the scores transcribe across different measures. That's another good way of looking at test results. That, of course, is not quite at the level of equating, and equating is literally a transformation of one scale into the other, which gives you a direct accounting or a direct map from one test to another. And equating is something that we'll talk a little bit about hopefully in week 10. Both great answers. Thank you, Corinne and Joel, for those. Okay. All right, no more hands raised. Then I will, again, this construct map is already posted on Canvas, and it should be quite as simple as just replacing the scoring instructions with the item descriptions that you had from last week. So most of you have really dialed in the construct definition at this point. Leave that alone for now. If you do have a fixed scale that's assessment specific, which most of them will be, analyze it a little bit and tell me how the information that's presented could be improved. Now, you might come across a situation where the assessment not only has the scaled score, it also has all the achievement level descriptors It tells you how that score maps over to like a Lexile ranking, for example. So the information that you come across in the technical report, you may be kind of at a loss, like, heck, I don't know how to make this better. This seems like it has 3 or 4 different ways of interpreting that score. That seems pretty good. And that's a perfectly fine response for this item. So this last, the recommendation section of the construct map assignment is really if you see some kind of glaring weakness. If you don't see a glaring weakness, then your assignment is to describe the strengths of the interpretation guidance that the technical reports include, and that's perfectly acceptable to you. All right? And if your questions don't occur until this weekend when you're dedicated to doing this work, shoot me an email and I'll get on top of it and get back to you. Okay. So that is the 3rd version of the construct map. I'm going to go back to the Animoto instructions now. So we covered all the information that's here. And then this is the if statement that I was highlighting with the recommendation in the bottom. So if the scoring is based on a scale, so that can be 0 to 4 or Goodman or other selected response type items, or any fixed scale, provide recommendations on approaches or innovations that might be used. So what that is really geared at is, do the scores that you're getting from this test make sense to you as a user? Has the technical report or the score report that's embedded in the process, is it giving you the information that you really can use to make comparisons to other kids, to understand what the performance means if it's more of an achievement level description approach, but to make sense of it in your classroom with your students or in your school with your teachers, in your school with your students? Do they know what that score means and how to march forward in terms of instruction or behavior supports, etc.? Okay, I'm going to do a quick scroll for questions here. All right. So this next part is part of these 2 sections here, and I might even highlight them. These 2 really apply to the construct map. So that can be submitted as a separate aspect. This first bullet is going to be in your Animoto. I'll even label that. Okay, so the next window that you look through, and this will be back in the Animoto video now, if I spell it correctly, is to look at the uses of the measure. So both of your measures, look at each of the recommended uses and write a brief summary. It could be literally enough information to fill 1 PowerPoint slide about the primary weaknesses you see in terms of what you've learned about the assessment so far. Some of this work is going to be easy for those of you who've already focused on this topic as one of your interesting aspects. For example, one of the things that sticks out to me is the Arizona merit test had some really kind of questionable test administration practices that didn't seem to be equitable. So that particular group, that'd be an easy thing to focus on. Why? How does that make sense? How does that give every student a fair chance to demonstrate what they know and can do? If a rule that forces them, for example, to complete a test that isn't the test they should be taking is put into place, etc. Oftentimes there are some policy rationales behind those procedures. I'm not interested in the policy rationales at all. I'm interested in your analysis, your independent analysis of the test, and whether it could be something that is useful for you in your work as a teacher or as a principal. You can also start considering, I think my most compelling argument, or the argument I would make that would support testing the most is as a parent. I didn't really feel like I had information I could trust coming from my school until standardized tests were put into place. And my initial experience as a parent was in New Mexico. And literally the only feedback I was getting from teachers was, progress reports and grades, but it wasn't really telling me whether my daughter was learning to read or how well she was reading or what grade level she was reading. So it was about the same time that the Dibbles was coming on, and I finally got a Dibbles score report from my daughter, and she wasn't meeting the kindergarten benchmarks for reading. And I know that she was just doing super well at school. So this was kind of a disconnect to me. How can you be doing really well in kindergarten and not learning how to read? So we quickly realized that once we got the scores back that there wasn't a whole lot of instruction going on in the room about reading, which is shocking, I know. But we moved her into a different school with a different teacher, and within 3 months she was reading 2 years above grade level. So that's one small story, but for me it gives or conveys some of the power of providing the public and parents with standardized test results. The data in a lot of ways don't lie. Of course they always have to be interpreted, but they do give us a way of really gauging what students are doing in the classroom in a manner that kind of can't be biased to the same degree that grades can be. So I appreciate that aspect. So again, this particular bullet, you can think of things like the purposes of the assessment. Sometimes tests are used for purposes that are outside of their stated use or stated purpose. That would be an area that you could talk about here. It's very rare that a technical report will tell you that it should not be used for a particular application. For example, how many state achievement tests say explicitly that they should not be used for teacher evaluation? None of them say that. Almost all of them are being used for teacher evaluation systems. But the fact of the matter is that they were not designed for that purpose. They were designed to provide reliable aggregate results for accountability purposes, to be able to rate schools and districts in the different categories of originally AYP and then annual measurable objectives. So those are the kinds of things that leave an assessment kind of subject to criticism. All of those things that you've learned about your measure can kind of come in this section. And it doesn't, I'm giving you many, hopefully examples of things you can think about. I'm really only expecting you to kind of focus on one thing per measure. Like, give me the one thing that kind of really sticks out to you about each of the measures and what you would recommend, how it could be fixed. And I'm expecting there'll be some questions about that, because that can be a little bit nebulous of an idea sometimes. If you have a question you want to levy, go ahead and raise your hand and I'll unmute you. Okay. All right, well, apparently I'm hoping then that you guys have some good ideas about how to tackle that. All right, so in terms of the Animoto aspects then, you're literally going to be incorporating 2 additional features into the Animoto, which is the video component. So you're going to be incorporating the scoring rubrics, decision rules, and guidelines for each measure. So that's probably going to be about 6 slides. So 1 each topic per 2 measures. And then you're going to be giving me 1 slide per measure about what's the big issue, what's the take-home message that you have about the way that this test is being used, or the way that it's structured, or one of the administration expectations that just doesn't make sense given what you understand about accessibility, equity, or reliability, or the fact that tests that are designed for one purpose are rarely good for anything else. I like to use a motorcycle analogy on this one. I don't know if any of you are interested in motorcycles, but a lot of times we will design an assessment to like a motorcycle, to be really good on dirt. You know, it's called a dirt bike. And the dirt bike is great for, you know, riding on sand or riding in dirt, riding on trails. It's not so good for riding on highways because the tires don't work as well. It doesn't have turn signals. It doesn't usually have a headlight. It usually doesn't go that far on the same amount of gas, et cetera. So there are a bunch of things that dirt bikes aren't good at doing on roads, right? So if you want to ride your motorcycle on the road, you're going to use a street bike or something with turn signals and a headlight and something that's safe and viable on the street. Alternatively, the street bike is not so good at riding on the road because it doesn't have knobby tires and it's going to dump out and you're going to break your turn signals and you're going to break your rear view mirrors the first time you wreck. So that's my test analogy. If you design an assessment, it's kind of the same thing. You can't design an assessment that's good at doing more than one thing most of the time. You really have to pick a singular purpose and design the items to target that particular purpose or that particular use. Now, that being said, you can design academic tests that look at different constructs. Like it can look at reading kind of as a separate issue and look at math kind of that as a separate issue and do a really good job of measuring math and a really good job of measuring reading kind of separately. And then you can combine those scores in a composite score. That's not exactly what I'm talking about because the measurement itself is kind of at the subdomain level in that particular case. So that's not it's not a purpose or a use, more as a way that the scores are aggregated. Where was I going with this analogy? I was just trying to give you a little bit more of a window into test purposes. I think the stated test purpose is a huge and overlooked factor, and it's the most singularly important thing that you need to consider when you're selecting a test for a particular application in your district, in your school. What was the test designed to do? Is that exactly what you need it to do? And can it do that for the kids that you want it to be effective with? But the purpose statement is one that's often ignored, mostly by policymakers, because either they're put in a tight situation by legislatures, where they have to use a test for a purpose that it wasn't designed for to be compliant with the law that's put in place. And they didn't get really a good chance to explain why that's happening. So then color-coded, the two center bullets that's information that goes into your construct map only. So you're adding information related to the first bullet and the fourth bullet to your Animoto video project. The information in the two middle bullets is going into your construct map. Any questions about that for Animoto 3? All right, I see a question. Kevin, I'm going to unmute you again. Go ahead.
I just want to clarify the the stuff that's going into the Animoto. Do you want that in addition to what we've already put in the Animoto? So we're like adding slides to what we've already created, or are we creating, say, a new set of slides from scratch that has this information, but not the information that was in the previous Animoto?
That's a great question, and I'll leave that up to you. Some of you have just been adding slides as all of the projects have come along because you kind of have seen this neat kind of metamorphosis of how you understand your measure developing. Others have just submitted the information that's due for that specific Animoto. Both are acceptable to me.
Okay, thank you.
Yep. All right. I don't see any questions in the question box. Oh, wait. Oh, good. All right. So that, somebody else had your same question, Kevin, so that got answered. Yeah, that's up to you. I kind of, it's neat to see the development of the Animoto 1, then 2, then 3 kind of on top of each other from your perspective and from mine. But I totally understand if you want to keep each of these things separate because that makes it a little harder to pick a song that's long enough. So there are a couple other complicating factors that go into building a big behemoth of an Animoto. So if you want to just do the slides that are relevant for this project, that's completely fine. I'll post this version that has the highlighted sections on Canvas too, because that might be helpful. Okay, so we actually, because of Halloween, missed 2 weeks worth of information. So last week was the topic was advanced reliability, and I'm going to provide a week 6 overview of that. My original plan was to give you the last 20 to 25 minutes to get into your groups on Zoom and plan the Animotor 3 response, divvy up who's going to do what, etc. That is not going to work with a GoToWebinar interface. However, I still do want to give you that time if that's at all feasible. So I'm going to try to be done with reviewing week 6 and week 7 content by 7 o'clock. So that's about 37 minutes. And then I'm going to just have to ask you all to use the systems that you use to communicate normally, whether that's Google Hangouts or setting up a Google Doc that you guys all can call into and comment back and forth on. But I'll make sure that class is over by 7 so that you have the freedom to pursue that if that's an option for you. If you're not too worried about it, then we can just be done by 7. Okay, so all the news that's fit to print about reliability. So there was quite a lot of information about Chromebax Alpha. Deservedly so. Chromebax Alpha is probably the most common reliability metric that you're going to come across. That's still true, even though it's a number. It's a rating that has been misinterpreted more often than any other as well, probably because of its extensive use. So reliability is concerned about score consistency over replication. So if you give the assessment multiple times to the same student, how do those results compare, for example? So what you do is you look at the standard errors across replication. That gives you a measure of score consistency. You can also look at generalizability of the items, occasions, and raters. We're going to talk more about generalizability in a couple weeks, so I'll give you more information there. But what that is literally trying to do, the idea of generalizability theory, which is what this is referring to, is looking at the sources of error that are inherent in the items versus the sources of error that are inherent in the occasion, or another way of thinking of occasion is the test administration. And the sources of error that are inherent or tied to the rater. And generalizability theory literally doesn't just talk about those sources of error, but actually provides a numerical accounting for them so that you can kind of remove or set aside the error that's related to those 3 things and focus in on the score variance that's related to the construct and the student in a kind of a filtered way. So it's a really important concept that we'll go over in more detail in 2 weeks. Next week, actually. So the IRT information functions that we went over in week 5, the item characteristic curves and the test information curves, those again give you information about how the items are functioning across the distribution. So at every single point across the distribution, and the test information functions show you how the tests are functioning across a given scale or in comparison to each other. So again, I talked a lot about the advantages of IRT because it gives us reliability at the item level. Historical or classical test theory only gives us reliability at the test level. So it was a test level measure. Now we're actually looking at how items function in and of themselves, which gives us much more information than we've had in the past. And then another thing that we look at is classification consistency. So how reliable are the tests in assigning the student into the appropriate category, and that's connected to the diagnostic efficiency concepts that we covered prior as well. So this student was labeled by this test as being at risk for reading failure. Did that end up being true when compared to the gold standard of whether or not that student experienced reading failure by grade 3, etc. So there are a bunch of ways that we get at measuring reliability. Those are the different kinds of considerations that we look at when we're looking at score consistency. So the reliability coefficient is another concept that was addressed in the readings, and generally they're correlations between what are called parallel test forms. There are different ways of dividing up tests so that they are considered parallel. One of the most common ways historically was if you had a test that had, let's say, 40 items, you would take all of the odd numbered items and correlate them to all of the even numbered items, and that would be your parallel test form correlation. So we've evolved a little bit since that. The Cronbach's alpha is actually the average of all of the possible split half reliabilities in a test. So it's literally, it's the most summative split half reliability coefficient that you can come across, because it takes every possible half test and compares it to every other possible half test and gives you an overall correlation estimate. So it's certainly an advance, and it was very innovative for the time, Cronbach's alpha certainly. And the Spearman-Brown prophecy is just kind of another generation of the Cronbach's alpha with a couple different decision rules. So I'm going to harken you back to the classical test theory, so CTT, which is the observed score being composed of a true score, and the true score, of course, we never really know, combined with error. So there are two different kinds of error that are concerning. One is systematic error that affects all examinees equally, and the other is random measurement error. So when we're talking about classical test theory, we're really not interested in systematic error. Those are issues that should be corrected through administration or policy changes. We're really looking more at the random measurement error. And reliability, of course, is looking at or trying to estimate the sources of error, because the more we're able to actually account for the error, the closer that we're able to get to the true score. That's kind of the general assumption of generalizability as well. So the more we can define the error, in other words, specifically how the score is misrepresenting the true score, the closer we get to true score estimation. And the statistics that you'll see most commonly include the standard error of the measure. And the standard error of the measure is literally the observed standard deviation times the square root of 1 minus the reliability coefficient. And it's used to generate confidence intervals. So I know that you've all heard about 95% confidence intervals, 68% confidence intervals, etc. Those are really important for interpreting test scores, of course, to parents, to teachers. But they're also important because they convey the assumptions about classical test theory. So you're literally taking an observed score, which is the score the student got on the test. You're using how reliable the test appears to be statistically with the reliability coefficient, and you're calculating the standard error of the measure. In other words, what range of test scores on that particular assessment are we 95% confident the true score exists within. So if that's the range of error that you're talking about, then you're talking about a pretty good guess about where that true score is. Of course, the higher your probabilities get, so that would be plus or minus 2 SEMs for that particular one, the wider the range is going to be. So the more that you're concerned about getting a range that includes the true score, the wider that range is going to be. So it's a catch-22 a little bit. And the confidence intervals on most tests, like IQ tests, they should depend upon where you are in the distribution. So if you're toward the center of the distribution, so you're more toward average, like let's say you have a test score of 100, for example, on an IQ test, so you're dead center on the scale. Your standard error of measure at the middle of the distribution is going to be much smaller than it is at the tails, because tests are much more reliable when they have higher sample sizes. That was something that the readings made very clear. There are a couple factors that affect reliability. One is how many students are participating. So where you have the most students is always going to be correlated with where your test is most reliable. So as you start bleeding out on an IQ test toward the lower end of the measure, so you're getting scores that are 2 or 3 standard deviations below the mean, the standard errors of measure are becoming massive. So you'll find on an IQ test that they're in the 10 to 12 point range. when you get farther and farther from the mean. The same is true for high IQ scores. So people who are very smart and walk around saying, oh, I have an IQ of 245, there's a really easy answer for that. Like, you have no idea if you have an IQ of 245. There's no way. You could be 60 or 80 points off with that particular guess, literally, because the tests aren't reliable that high up the scale. They're really reliable between 130 and 70. Outside of that, it's better than guessing, but it's super unreliable. So you can use that to bring somebody down a notch if you need to later in your life. Okay. So then there are different types of reliability, or different ways that we go about documenting or gathering reliability evidence. So there's test-retest reliability is literally giving the student the same exact test on different occasions. So you'll give it to them 1 week. You typically try to wait a certain period so they forget about what was exactly on the test, and then you give them the same form again. You can also have alternate form test-retest reliability. So if you're looking at Form A and Form B, you give Form A to them first, and then on the second occasion you give them Form B, you've already done some equating with Form A and Form B, and you know how the scores correlate to each other, or how they can be transcribed onto each other's scales. Then that's another way of getting it test-retest reliability. And again, what that does is it addresses the question or the source of error about occasion. So sure, the student did really well on Wednesday right after lunch. Will the student do just as well on Friday afternoon, a half an hour before they're supposed to get on the bus? Of course, the test can't explain those kinds of fluctuations. Those are kind of separate, so you would want to dial it in. But the idea is that tests perform differently depending on when they're administered to the student, even when the student hasn't really changed in between the time periods per se. So we're also looking at inter-rater reliability. So this is incredibly important when the teacher or the rater is the one doing the scoring, like for performance assessments. This is looking at different raters on the same occasion. So for an inter-rater reliability study, you usually have a teacher who's responsible for the student giving the assessment, and you have an expert rater more often than not sitting off to the side and watching the test administration and scoring the assessment at the same time that the teacher is, and then you literally compare the two ratings, and they should be highly correlated, right? Because an objective expert rater should get a scoring system that matches the teacher's almost perfectly. Of course, for different item types, that's more complicated, and Kevin was mentioning that on SPEC, even the different items have different scoring rules. So the more complicated your scoring rules are, the more inconsistency you're going to have between raters. That's kind of a rule of thumb. Writing historically writing items have been difficult to score compared to selected response, etc. So when you're thinking about those kinds of issues, and scoring writing is one, they typically have writing samples scored by at least 3 raters, sometimes up to 6. If the first batch of 2 or 3 raters are consistent, in other words, they agree, then they don't go to a second round of scoring. If there's any disagreement in the first round of scoring, they go for another round, etc. Because writing is much more difficult to score, even when you have a pretty specific rubric and examples of what each of the levels mean. Writing has so many permutations, sentences have so many permutations that it's hard to capture everything that is possible to write in the English language, in our case, in a scoring rubric. So then, so that's inter-rater. So looking at how different raters interact with the same assessment occasion and the same student. So that's another aspect of reliability. Finally, we're looking at internal consistency, and that is basically how well the test hangs with itself. The danger with Cronbach's, and this was talked about a little bit in the readings, is that you can have an assessment that has a really high reliability coefficient, and it's related not to how well the test hangs together necessarily. It might be related to how redundant the test is. You could have a test that's composed of items that are almost all exactly the same. They're testing the same exact construct. So those items are going to hang together, and it's going to look like a really internally consistent test, but it's not going to have the kind of educational or content reach that you might need from it. So you need to remember as a caveat that having high Cronbach's alpha numbers isn't necessarily a good thing. It can also be pointing to the fact that your assessment is simply redundant. So there are a lot of items that are giving you the exact same information, in which situation you're wasting test administration time, both of the student and the teacher, as well as all the scoring. So I already talked about Cronbach's alpha being the mean of all possible split half reliabilities, so it was an advance in that regard. It nonetheless, in almost all cases, provides an underestimate of true score correlations. It's often misunderstood and misinterpreted, meaning that there are no real hard and fast rules about what is an acceptable value or criteria. Typically, if you're considering high stakes applications, so there are consequences that are important for the student or the school or the district, you're looking at reliabilities that are in the 0.90 or better range. And then, again, this is at the test level. Most assessments are, most high stakes assessments are well above that these days. They're in the 0.94 to 0.98 range more often than not. Diagnostic instruments, that's a different story. The stakes aren't always as high for diagnostic instruments, so they typically can get away with some lower correlations. Cronbach's alpha ratings. So the factors that affect Cronbach's alpha were talked about in Ponteroto and Ruckdeschel. They include sample size, number of items, inter-item correlations, and the standard deviation of the scores. So larger samples, more items, increase reliability estimates. Higher inter-item correlations increase the Cronbach's alpha as well. And then lower standard deviation of scores also increases the Cronbach's alpha. All of those things affect your interpretation of what the Cronbach's alpha really means. So make sure you take them into account. The other point that is made in the article is that internal consistency is a necessary but insufficient condition of unidimensionality. Cronbach's alpha being high doesn't tell you that the test is measuring one construct. It's really insufficient evidence. If you didn't have a high Cronbach's alpha, you could know that your test isn't unidimensional, but the flip side of that isn't true. Having a high Cronbach's alpha doesn't tell you that a test is unidimensional. You actually have to look at the factor structure of the assessment, because as I mentioned, high Cronbach's alpha ratings could just mean you have an absolutely redundant set of items. So that could point toward unidimensionality, but in a way that you're not intending. So you really want to look at factor structure when you're talking about the dimensionality of an assessment. And that last point I've already made quite a lot, which is redundancy is one of the critical factors to consider when you have high Cronbach's alpha ratings. So here's a matrix, and this is right out of the reading. It basically gives you the factors to consider when you're thinking about the number of items, the level of rating, and the sample sizes that you're considering when you're trying to interpret internal consistency coefficients like Cronbach's alpha. So this is something you can use as a general rule of thumb if you're having to interpret Cronbach's alpha in application. But it's something that you're going to probably have to argue about with your committee. So it can help if you have a citation like this. It can also help if you just know, like, listen, Cronbach's alpha isn't necessarily a measure of unidimensionality. There aren't really tried and fast and true rules that I can follow. Given my experience and the experience of researchers like Ponteroto and Ruckdeschel, it seems to me that a rating of 0.88 on this assessment, where I had 300 students and 6 items per subscale, is probably sufficient evidence of internal consistency, because you can look at this number here. But using kind of conditional language like this, likely, probably, can help when you're having these sorts of discussions, because they're all about interpretation. So the reliability takeaways. One of the things that you need to recall from the articles is that reliability is inversely related to measurement error and directly related to validity limits. And that's literally because of how the reliability coefficients are included in the equations that we use to calculate validity aspects. So the measurement error, so the less measurement error you have, the more reliable your instrument is. So that is what inversely related means for that. Another caveat, so more items is more reliable, more raters is more reliable, more occasions is more reliable. So more makes it more reliable. Why is that true? Because you're looking at consistency. It's best to look at consistency over time. The more times you look at something, the more you're going to hone in on what the actual or true value of that particular application should be. Generally, what we're trying to do when we consider reliability is considering the sources of variance. In other words, what aspects of the test context result in changes in test scores. What we want in a perfect world, the only thing that affects a student's test score is the student's internal or latent ability, right? But we know that doesn't happen because items aren't perfect, tests aren't perfect. Occasions present factors, even when they're random, that get in the way of measuring the true score. And raters, when they're involved in scoring, also are sources of error. So classical test theory wants to go through the process of understanding that and then accounting for those sources of error and then actually estimating them so we can get closer and closer and closer to the true score. So reliability is important in terms of how it's related to validity, as mentioned in the first bullet, but low reliability compromises the power of the assessment to identify true relationships among the variables you're considering and lead to higher type 2 errors. So generally, if you have low reliability, you're going to fail to reject the null hypothesis when it actually should be rejected. In other words, you're finding what you want to find, but you don't realize that you found it because your measures weren't reliable enough. It also can lead to false negatives. This last point is something that's important too because it shows you a relationship that's not reflexive. So test result interpretations cannot be valid unless the scores are reliable. However, test scores can be reliable without yielding valid inferences. So you can have a test that's super consistent, but it's not connected to the use or the interpretation that is important from a validity perspective. However, you can see because of how reliability coefficients are included in most of our analyses of validity that a test has to be reliable before it can be valid. A test can be, that's exactly, I don't want to say anymore because I think I'll just confuse you. It's actually the way it's written is perfect. Any questions about that so far? All right, no hands raised. Okay, so this one is just trying to get, again, revisit the topic of type 1 and type 2 errors. We talked a little bit about this during the week where we discussed diagnostic efficiency. But I wanted to introduce you to the concept of power. You're going to be talking about power over the next 2 years. And what power is it's 1 minus beta. So it's literally your type 2 error rate, which is your false negatives. With 1 subtracted from that, or 1 minus that rather. So what it is, what power is it's the probability that you'll be able to reject the null hypothesis when it is in fact false. So when you're talking about the power of a study, that's what you're trying to assess. How likely are you to reject the null hypothesis when it is false? In other words, how likely are you, given your sample size and the type of test that you're using and type of modeling that you're doing, in finding what you're really trying to discover. So power is going to become an important topic as you work forward. So generalizability, again, I talked a little bit about this on a prior slide. We'll talk about the difference between estimating all potential sources of error and then how classical test theory approaches that. So generalizability builds on classical test theory, but it starts using different words that have different definitions and different applications, like universe score variance divided by observed score variance, etc. And it's an important shift in the field from classical test theory, and I'll go into more detail about that in week 9. So this week already happened, so all of that work is already underfoot. And now I'm going to transition to reviewing week 7, which is validity topics. All right, I still don't see any questions in the question box or hands raised. So modern validity theory has resulted, the article that you guys read talks a lot about the historical development of validity. I'm going to gloss over quite a lot of that. I'm going to talk more about kind of where we are now. I'll mention a little bit about the development over time. But basically what happens is our understanding of validity has shifted quite a bit. We used to talk about the validity of tests. We know that its validity is not an aspect that's inherent to tests anymore. Validity is more about our interpretation and uses of the results of the test scores. So that has been developing over time. We've also been developing different ways of looking at validity, partially because of advances in software that allow us to do these crazy calculations that we weren't able to do before, and partially because we started thinking of new ways to look at tests, new sources of error that we could help address, etc. So it's been this long process. And it's resulted in two of probably the best known, at least in measurement, validity theory, discussions that are led by Messick and Kane, and I'll talk a little bit about them here in a second. Messick's general approach to validity treats it as if it's more of a scientific process. You have a hypothesis, and you go through several procedures gathering evidence. Once you look at that evidence and find the patterns, then you test your hypothesis of whether or not the assessment is valid for the intended uses that are defined for it. If not, you try to figure out ways to bring it up to that space. So he kind of approaches validity generally as more of a scientific process where it's hypothesis testing, and you're doing small studies and experiments to test the validity of our interpretations of test scores. Kane, on the other hand, and their approaches aren't wholly inconsistent or different. There's quite a lot of overlap. They just have kind of different theoretical frameworks that they approach their work in. Kane is more of the legal bent. So his approach is generally more of the, well, I have a claim that I want to make about this particular test and how it can and should be used. So what I need to do is put it in front of a jury and present my case. I need to have all of my evidence. I have to present my evidence. I have to look for all of the patterns in my evidence, and I have to convince in the jury, and in our case that would be test users, test consumers, that this particular assessment is useful for its intended purpose. So those things, you can see, they're not exclusive, they're not mutually exclusive, but they are different ways of thinking about validity. And both of them have people who support them more versus the other. I think either is really sufficient, and I think the types of evidence you end up documenting to address validity and documentation of validity, whether you're using a Messick hat or a Kane hat, you're going to kind of end up arriving at a very similar place. But it is a different way of thinking about the process. One from a more legal, where you're making a claim and you're having to provide some warrants and data, et cetera, that prove your claim. The other, you're making a hypothesis and you're going out and exploring and try to find information that you can gather to tell you whether or not your hypothesis holds water. So sources of validity evidence include content, and that's typically alignment studies or cognitive labs, where you're literally looking at what's the stuff that's on the particular assessment, and does it match the stuff that we know about the construct. You're also looking at construct, which would look at test structure, so factor analyses, dimensionality studies. Generally, when you're talking about construct evidence, if you have an assessment like SBAC, for example, where you might have an overall English language arts score, you might yield separate reading, writing, language, listening, speaking subscores. That's not true in Smarter Balance yet, I don't think. But those dimensions that you're scoring or you're reporting on really need to be, you have to have some evidence that those dimensions exist. So they're actually evident in your test. Otherwise, you probably shouldn't be reporting them. You should just be reporting your assessment as unidimensional. So test vendors, test developers go through factor analyses to provide evidence that their writing items really are kind of functioning differently, and they're functioning differently from all of the other items, but they're also functioning pretty consistently with each other. That kind of shows me that I'm pretty justified in giving a writing subdomain score on this particular test. Whereas the math items, they don't really correlate very well with the writing items, but they're pretty highly correlated with each other. And this, using the word correlation, is I'm using it loosely because it's really more about seeing factor loadings on latent factors, which we'll talk about in a bit too. But any dimensionality studies, we're actually trying to see literally, according to the data, how many constructs are you measuring. And then sometimes you're trying to define what those constructs are because you may have been wrong, your test design, and your items may be functioning in ways that you did not intend. So criterion validity is looking at conversion, so comparisons with other measures. That can be either predictive, where you're trying to take performance on one assessment and predict future performance on a different assessment. It can also be concurrent. So you're giving an assessment or two different assessments that are on the same construct to the same kid at the same time and trying to compare them. Oftentimes with concurrent validity, you developed a new measure and you're trying to show that it's relatively consistent with other measures of its type in the field, just as a way of convincing your users that it's a tool worth buying. So convergent validity evidence is evidence where you're literally trying to measure the same construct as the other measure, and you're comparing it to show, yep, look, I'm in the right ballpark. I'm 0.92 correlating with this particular measure of reading fluency and my measures of reading fluency, so that gives me some convergent evidence. If I take my reading fluency measure, however, and I compare that with math calculation measure, that correlation should not be 0.92 or 0.96, right? Those are different constructs. I'm measuring different things there. So that should give me evidence of discriminant validity, meaning my reading fluency test is not measuring math calculation as well, or at the same time. And then the aspect that Messick introduced, which remains relatively, well, if there is anything that's gathering news and validity theory, it would be consequential validity, which is looking at unintended and intended consequences of test uses and scores and score interpretations. And again, those can be positive and negative. The question with consequential validity, to me, isn't necessarily it's a thing. It is a thing. The question is who's responsible for taking care of issues that arise when we look at the consequences of test uses and interpretations that are not supported by technical documentation. So Messick stated this is a really good definition. It's very thorough, and I'm just actually going to read it. So validity is an overall evaluative judgment of the degree to which empirical evidence and the theoretical rationale support the adequacy and appropriateness of interpretations and actions on the basis of test scores or other modes of assessment. So he actually has said a mouthful there. So it's an overall evaluative judgment. So you're making a judgment about the test and all of the information that you gathered about that test, all of the evidence, the theory behind it, your evidence about the dimensionality, all of that stuff goes into one bin, and you have to basically provide a summary that says, yes, this information supports this interpretation and use of this assessment. In fact, teachers should be able to use the results from this assessment to also adjust instruction, curriculum, etc. So any interpretation or use should be specifically justified by the overall evaluative judgment, but also by the evidence that's gathered empirically. Messick also promoted the concept of construct validity as being the unified or the umbrella term that all other aspects of validity come under. Because it's really about, are we measuring what we think we're measuring is the critical question to Messick. and the other aspects kind of give us support that aim toward that as our overall goal. So in addition to making sure that our assessment is reliable, because of course that's the first step in ensuring that it's valid, we look at, for Messick, he divides the categories into content, substantive, structural, generalizability, external, and consequential. You'll see quite a bit of overlap with what I've already gone over on the previous slide there. Generally, you want to make sure that the stuff that's on the test is measuring the construct correctly, that the scores apply across different samples. So for example, that can be an analysis of your norm group, and of course norm groups are designed to be representative typically of the United States based on census data. So if the United States has, for example, 55% white, 38% Hispanic, etc., you want your norming group to match that exact distribution so that your test results will generalize to the population that you intend. In this case, for the example I used, the United States. And then consequential is in italics because he really introduced that as kind of the next aspect of validity that folks hadn't really given much thought to. And it really is, when all is said and done, what the tests are being used to do is hugely important. For our work, it's everything. So I think he was right to draw attention to that aspect. It just begs the question of who is supposed to go about the process of making sure that tests are not used for purposes they're not designed for, and that people who are supposed to be using them are able to use them correctly. So threats to validity that he talks about are construct underrepresentation. So that can be a situation where you have you're trying to measure reading ability overall, but your test only has reading fluency, for example. That would be an obvious example. There also is construct irrelevant variance. So for example, you're trying to test math calculation, but your particular word problem goes way deep into the weeds and gets into some historical story about a specific country, et cetera, that really doesn't have anything to do with whether or not the student understands how to add 2 plus 2. So anything that is getting in the way of what you're actually trying to measure, like the specific skill that you're trying to measure on an item, is construct irrelevant variance. It's just noise that you need to separate out from the item. Kane, again, he's the one who kind of provided a little bit more of the historical context. And he talks about construct validity in a little bit different way. But the primary point from Kane, I think, is that validity is an argument that you support by claims and evidence. So you make claims, make an argument, and you present your evidence. And he kind of does give a little bit of Messick. Of course, he came after Messick, so he kind of took what Messick learned and kind of applied it in a little bit different context. But his definition is that validity is an interpretive argument that survives all reasonable challenges and can be provisionally accepted, with the caveat that new challenges may arise in the future. So Kane obviously saw validity not in kind of a scientific way in that sense, because he thinks validity is always validity evidence is an ongoing process. You're never going to stop gathering validity for an assessment, and I think he's right about that. So it's not scientific in the sense that you do something once in time and there you go, boom. It's been replicated 4 times. This test is valid for this particular use and interpretation. That's not the way it works with tests. We're constantly driving new changes and improvements to make the test better and better. So Kane's approach in that respect can be considered superior. He understood that any argument or claim that you make about an assessment is only good until the point where it can't survive a new challenge. So there's something that might be learned in the field, changes the way we think about how that assessment should or shouldn't be used. So Kane's interpretation of Messick was basically that he appreciated him and he advanced the field, and that validation can include evaluation of the consequences of test uses. He wasn't necessarily sure, Kane wasn't, that those consequences were the responsibility of test developers, which was generally kind of Messick's viewpoint. But they both agree that validity involves evaluation of interpretation or uses of test scores. It's not an aspect of tests themselves, and that the degree to which your evidence supports your interpretation is what's required in terms of the documentation of validity. And that, of course, depends on the type of assessment that you have. So there are several examples that I could walk you through. This is just a couple screenshots of 1 year's technical report where we look at and gather a variety of aspects of validity. So from consequential validity studies to inter-rater reports to alignment studies to scaled scored interpretation guides. So just to let you know, like in Oregon, this kind of work is going on with SBAC, with the Oregon Extended, with the kindergarten assessment. These test development expectations are prevalent, they're common. We try to all adhere to the standards in our work, and there literally shouldn't be any of the stones that we've discussed in terms of what's required for a reliable test interpretation and a valid test interpretation. You should have evidence that shows that your assessment, all of the components of your assessment, are sufficient to its purpose. So you can see this is just an example of all of the appendices that went in the last year's technical report for the Oregon Extended Assessment. And that information gets submitted to the U.S. Department of Education, and they have a group of peer reviewers who are experts from other states who actually review all of Oregon's evidence and basically tell us whether or not the claims that we're making, that in this case the Oregon Extended Assessment provides reliable information about students with significant cognitive disabilities and their performance in English language arts, math, and science each year, that are sufficient to the purposes of annual measurable objective reporting. So we have to document evidence for that every year. And I'm going to get going faster here because it's already after 7. So again, validity takeaways. This is based on Messick and Kane. The tests in and of themselves are not valid. It's the interpretations and uses of test results that must be validated through the process of documenting evidence of validity by looking at inter-rater reliability, internal consistency, dimensionality, or factor structure, all of those things that are relevant for the assessment depending on the construct that you're looking at. So validation is in fact both scientific and evidentiary because you don't know what you're going to find in your studies, and you also have a hypothesis that you're testing. Of course, your hypothesis, if you're a test vendor, is, yeah, sure, of course my test is reliable, but then you have to go conduct a study and use expert reviewers, et cetera, to help you come up with evidence of that claim. All of the threats to validity should be addressed in a technical report as well. So if there are rival hypotheses or other explanations for the patterns that you're seeing, you should address them and explain why they can't possibly be a viable explanation for the results you're seeing. That's kind of similar to a scientific or a research article as well. You should address construct underrepresentation. So you should have evidence that if you're testing reading, for example, that you're testing all aspects of reading, not just reading fluency. You should also show how you eliminate sources of construct irrelevant variance. One example of that would be, well, every year we train all of our teachers on how to administer the assessment appropriately, and they have to pass a proficiency exam, which we document, that shows that they understand our expectations about how the test should be administered, scored, reported, and interpreted. So that's how we try to eliminate construct irrelevant variances through increased standardization of the test administration practices, et cetera. That's one example. And I like AERA's response that I cited for you here, that validation is the joint responsibility of the test developer and the test user. So when you're getting at that consequential validity question, there's no doubt that consequential validity is an important aspect to consider. There's also no doubt that we're all responsible for appropriate test use. So the test developer is responsible for supporting the uses that they are promoting. They're also responsible for really describing how the test shouldn't be used as well, although you won't see that as commonly. And test users, of course, are responsible for being aware of all of those informational aspects that the test developer publishes and then not using the assessment results for purposes for which they have not been validated. And then Messick has a nice statement at the end. So this makes explicit what has been latent all along, namely that validity judgments are value judgments. What that means is that validity is a social project, a social process. So most of the evidence, most of the studies that I'm talking with you about, the source of information from all of them has to boil down to, at this point, experts in the field, like for alignment studies, et cetera. We don't have ways of generating all of the information that we need in a technical report just by purely analyzing data. So it's a combination both of value judgments of the methodologists, value judgments of the statisticians, and then value judgments of the teachers or behavior specialists or whomever is involved in the item development that is really important. But they are all value judgments. No one tells you whether or not a particular source of data is sufficient. You have to use your experience in comparison to other sources of information to make that judgment. Okay, so coming up in week 8, we'll look at factor analysis and construct validity. So as I promised, unidimensionality or the dimensionality of assessment really needs to be directly assessed, and factor analysis is one way of looking at that. You'll have one reading, which is Thompson and Daniels about factor structure. There are 2 videos that you'll watch, part 1 and 2. And then if you can review the Enomoto 4 instructions prior to class, that'd be great. And of course, Enomoto 3 is due this coming week. It's due before class starts, right before class starts, so 5 o'clock, 5:30, excuse me, because we're going to be discussing it as part of next week's class, and then also discussing Enomoto 4 instructions. So I'm scrolling over here to look at questions. I will hang on. That is it for class today. You guys are welcome to use the next, sorry it ended up only being 11 minutes, to at least make arrangements to get your Enomoto 3 project off the ground. I'll stay on this GoToWebinar meeting too. If you want me to unmute you, just raise your hand if you have any questions either about the Enomoto 3 project or the reliability or validity information that I presented tonight, or reviewed, actually. So I'll be on this link until 7:20. If you do have questions, just let me know. And I'm going to stop the recording now. I